Today we are going to study third chapter of 10th standard, that is circle. So how we can define a circle? Circle is a geometrical closed figure and we can define it in this way. A set of points in a plane which are equidistant from a fixed point. The fixed point is called a center. Okay, now you can see here this O is a fixed point, and from this point O, these are the set of points, and all these points are equidistant from this fixed point O. Okay, so the point on the circle, let's take that point as A. So here the segment joining the point on the circle and the center is called radius. Okay, so already you have studied this in your lower class. In a 10th standard, what we are going to study about the circle? So dear students, in the 10th standard we are going to study how many circles we can draw from a 1 point, then 2 points and 3 points. So dear friends, now let's see how many circles we can draw passing through 1, 2 and 3 points. Okay, let's start with the 1 point. So here, let's take this point. Okay, now here, draw the circle passing through this point. Okay, then this is another circle. Okay, so in this way we can draw the number of circles passing through the single point. Okay, you might have applied this to draw the design. So if you will take all the circles of equal radii, you will get a beautiful flower. Okay, so from a point we can draw infinite the circles. Okay, now let's see how many circles we can draw passing through the 2 points. So here let's take the 2 points A and B. Okay, now to see that how many circles we can draw passing through these 2 points, let's join these points A and B. So we'll get the segment AB. Now we'll draw the perpendicular bisector of the segment AB. So already you are knowing that how to draw. So let's consider that this is the perpendicular bisector of segment AB. Now on this perpendicular bisector you can take any point. Okay, let's take here point O. You may take it upside or downside. So here I took the point O. Now we are knowing that the point on this perpendicular bisector is equidistant from the endpoints of this segment. It means that here this OA and OB both are equal. So taking OA as a radius, let's draw the circle. Okay, same way you may take the point downside. Let's take this another point P. Then take the AP or PB as a radius and draw the circle. Okay, then okay, so in this way here we got another circle. So on this perpendicular bisector, anywhere if you will take the point, so you will get the number of circle passing through these points. Okay, so number of circles we can draw which are passing through these 2 points. Okay, now let's see how many circles we can draw which are passing through the given 3 points. Now here it is not possible to draw a circle from the 3 collinear points. It is not possible. So now here we are going to take the three non-collinear points. Okay. So these are the three non-collinear points. Let's join these points. After joining this, we'll get a triangle. Okay. And in the 9th class, you have studied how to draw the circumcircle of a triangle. Okay. So here, to draw that, suppose we took this point A, B, C. Okay. Then to draw that circumcircle, you will draw the perpendicular bisector of any two sides. Okay. Then taking this point as a center and this as a radius, suppose this is O, then OB or OA or OC, taking this as a radius, if you will draw the circle, then you will get circle like this. Okay, so we can say that only one circle is passing through the three non-collinear points. So dear friends, here we can conclude that infinite circles we can draw passing through the point 1 and from 2 points, and from 3 points we can draw only one circle. So friends, from this example you might have come to know that what is the line tangent. So tangent, this is quite related with our real life. Okay. Now here you can see a circle with a center O. Near to this circle there is a line L. Okay. Now there is a distance between the circle and the line. Let's bring this line close to the circle. Okay. In such a way that this line touches to the circle in only one point. So this line L is touching to the circle with the center O at point P. So we can call this line as it is touching to the circle in only one point. That's why we can call this line as a line L as a tangent. And as it is touching to the circle at point P, so we can call this point P as a point of contact. Now again bring this line closer to the center. So here you can see that now this line L is intersecting to the circle at 2 points, that is point A and B. Now in this case this line L doesn't remain a tangent, because according to the definition of a tangent, a line touching to the circle in one and only one point, and we are calling that line as a tangent. But now this line L is touching to the circle at 2 points, point A and point B. Then in this case we can call this line as a secant. Okay, so this is the line L. This line L in this figure is a secant, while this line L in this figure is a tangent.
You may have watched a game of football. When the football is moving along the ground, or when it is stationary, it is in contact with the ground. At how many points is the football in contact with the ground at a given time? As you can see, the football is a sphere and it touches the ground at a single point at a given time. Look at this acrobat riding a unicycle on a rope suspended above the ground. At how many points does the wheel of the unicycle touch the rope at a given time? Here again, the wheel of the unicycle touches the rope only at a single point. Let's look at another example. Have you seen sparks fly off from a knife sharpening machine when a knife is being sharpened on it? In which direction do the sparks fly? You'll see that the sparks originate from a point and fly in a direction perpendicular to the radius of the circular knife sharpening machine. In all these examples, each line touches the circle externally at one and only one point. Such lines are known as tangents. The word tangent comes from the Latin word tangere, which means to touch.
Friends, it might be clear for you what is meant by tangent and a secant of a circle. Now we are going to study some properties and theorems related to the tangent. So our first theorem is tangent theorem. The statement for this theorem is a tangent at any point of a circle is perpendicular to the radius at a point of contact. It means that here there is a circle with a center O and it has a tangent line L touching to the circle at point A. So point A is the point of contact. So according to the statement, we have to show that this distance OA is perpendicular, this line L is perpendicular to the radius OA. Okay. So here, dear friends, you know that perpendicular distance is the shortest distance of a point from a line. Okay. So on this line L, there is a point A and this point O is out of the line. So OA is the perpendicular distance. If on this line L, if we will take any point, okay, let's take the point B, and if we will join this point O and B, so here definitely this point, this distance OB is greater than OA. Okay, by the Pythagoras theorem also we will get this as a OB as a hypotenuse which is greater than this OA. Or if you will take here, so this C, OC, distance OC is greater than OA. Or if we take this side E, OE, or in this way. So we will find out that this OA, distance OA is smaller than OB is smaller than OC. So from this we can prove that this perpendicular distance is the shortest distance. So here we can say that OA is as A is on the circle, so OA is the radius and it is the perpendicular because it is the shortest distance. Here if we take, so that point, this distance will be greater than OA. So in this way we can prove that this line L is perpendicular to the radius at point of contact. Friends, we have proved that the tangent is perpendicular to the radius at point of contact. Okay. Now let's see some more. Here there is a circle with a center O has the point A on its circumference. So here through the point A we can draw one and only one tangent to this circle. Okay, we can draw one and only one tangent to the circle. If you will draw another, so it will intersect the circle at 2 points. So from point on a circle we can draw only one tangent. Okay. Now if we take a point out of the circle, so here a circle with a center Q, okay, and there is another point P which is exterior to the circle. If we draw the lines in this way, so here we will get two tangents. It means that from a point to the circle we can draw two tangents. And here let's consider this one tangent from the point P touches the circle at point A and this another at point B. So here segment AP and segment PB are called tangent segments. Friends, we have studied the tangent theorem and tangent segment theorem. Let's apply this theorem to solve the example. So our first question is, in the figure, the radius of a circle with the center C is 6 cm. Line AB is a tangent at A. Then we are asked to answer the question. So here there is a circle with the center C has the radius 6 centimeter and there is a tangent at point A. Then our first question is, what is the measure of angle CAB? And we have to give the reason for that. So here, if we draw this CA, then CA is the radius. Okay, and this is the tangent at point A. Okay, so here we are knowing that tangent is perpendicular to the radius at point of contact. Okay, so we can say that angle CAB is equal to 90 degree by tangent there. Give that as a first. Then our second question is, what is the distance of point C from AB? So we asked to find out the distance of this point C from this AB. So distance is nothing but the perpendicular distance. So we have to consider this. So this distance is nothing but the radius of the circle, which is already given 6 centimeters. So here segment CA is perpendicular to line AB and CA is already given, that is nothing but the radius. So we can say that CA is 6 centimeter. It means that the distance of the point C from line AB is 6 centimeter. Let's come to the next question. Now next question is third. Distance between points A and B is 6 centimeter. Then we have to find out the distance between point B and C. So here in a triangle CAB, if we join this, so we will get the triangle CAB. Here angle A is equal to 90 degree. Already we have proved that. Okay. So here we can apply the Pythagoras theorem. So by the Pythagoras theorem, CB is the hypotenuse. So CB square is equal to CA square plus AB square. Okay. Now here AB is given 6 and this radius is given 6. So 6 square plus 6 square, that is 36 plus 36, that is 72. So we got the CB square as 72. But we have to find out the CB. So let's take out the square root from both the sides. So here CB is equal to 6 root 2. So we can say that distance between point B and C is 6 root 2 centimeter. Now last question is, what is the measure of angle ABC and Y? Now here in a triangle ABC, here CA is 6 centimeter, AB is 6 centimeter. It means that this both CA and CB are congruent, so each of a length 6 centimeter. It means that this triangle ABC is an isosceles triangle. Okay, as it is an isosceles triangle, that's why this angle ACB and angle ABC are equal by isosceles triangle theorem. Okay, now let's consider the measure of this both angle as x degree. Okay, so in a triangle ABC, sum of all these three angles is equal to 180 degree. That is angle CAB plus angle ABC plus angle ACB is equal to 180 degree. Okay, now let's put the value. Angle A is of 90 degree. This B we consider it as a x, C as a x is equal to 180. X plus x, that is 2x, and this 90 is a plus, it will be minus from 180. So we got that 2x is equal to 90, therefore x is equal to 45 degree. And this x is nothing but angle ABC. So in this way we got the angle ABC as a 45 degree.